Hello, everyone, and welcome to the scaling panel of our multi-chain infrastructure summit. To kick things off, we actually have great builders who are building super interesting different approaches to scaling. So we have Ye from Scroll, Yaoqi from AltLayer, and Rebecca from Saga. So we're going to cover the kind of context for scaling, go into some sort of considerations and thinking rationale behind how you design it and how you approach building scaling solutions, and then go into how it's going to look like in the future as well. So let's dive right into some quick introductions, right? So let me set the context here. We all know that monolithic chains are unable to meet this internet scale demand for block space. And we've been talking about that for years, about how so many chains are either slow or expensive. And therefore, everybody has been looking to scaling solutions with various archetypes. And I know each of you have very interesting takes on this. So let's do like a hybrid introduction where we can tell a little bit about yourself, what you're building, and also one favorite example that you always like to refer to that illustrates the need for scaling solutions. Why don't we start with Rebecca?
Absolutely. Shakai, thanks so much for having me. And thanks so much for hosting this multi-chain panel. It's a great opportunity to talk with fellow builders who are looking in the scaling space. But I am Rebecca Liao. I'm co-founder and CEO at Saga. So Saga is my second crypto startup. My first one was called SkewChain, and that was co-founded by myself, Zaki Mannion. I was one of the original builders in Cosmos, but that was more in the DeFi space. And then before that, I was building in AI. But Saga is quite special. So Saga is a chain to launch chains. We allow developers to automatically get onto their own dedicated chain. And we think of each dedicated chain, which we call a chainlet, like an AWS instance. So the way that most developers develop right now with respect to cloud is they stand up one AWS instance or several, depending on what their needs are for computing resources. And it's the same idea in Saga. We think that every developer should have their own block space in which to develop so that their applications don't face congestion. They have full control and predictability around gas fees. It's high performance. These chains are able to talk to other chains. This is the Cosmos thesis. And ultimately, you should be able to stand up as many of these as you like. That's the natural development rhythm of not just developing into one production environment, but several environments. And that's sort of a healthy way to build a project. And that's what we aim to provide to developers in the space. We are focused on gaming and entertainment because those are the two sectors that really, really need this kind of scaling technology. There's almost no tolerance for a bad user experience in those spaces. I think sometimes in other Web3 use cases like DeFi, because we're focused on other things like the financial return, the user interface is not quite critical. But in gaming and entertainment, it has to be fun. It has to be fast. It has to be responsive. It has to be a great emotional experience. And so you need really great infrastructure to support that. And that's what we're aiming to build. In terms of an example that I really love, so one of the partners we just recently announced is Come To Us, which is the largest mobile game developer in the world. They are based out of Korea. And they were originally on Terra. And once that didn't work out, they decided, okay, we want to be in control of our own destiny. And we are Come To Us. After all, it's a very big enterprise and they know how to make games. So they made their own chain and it's called Expla. They have found that with their volume, they're already running out of block space on that chain. So what they're doing is they're sending games and game developers onto Saga. So we're basically horizontally scaling the backend for Expla and other layer one. And we are on the back end. So we settle any sort of chainlet fees directly with Expla and Come To Us. And then on the front end, Expla has worked so hard to build these developer relationships, to develop other kinds of tooling that's necessary to launch a game. And they should reap the benefit of that. So they keep the relationship with all the game devs. What the game devs don't know is that their performance is super high and the cost of running this chain is relatively low because we are partnered with XPLA. But that's one way that two layer ones can help each other out. And that's what scaling is ultimately about. You see several examples like that in a smaller context as well, with games that are already established and they're looking to scale, or even with newer games that they're not necessarily looking to scale immediately because they're brand new, but they don't want to be constrained in their game design. And I think that the limits of the infrastructure can sometimes lead a game designer to be less creative, if you will, with the gameplay. But they want that full creativity, and that's what a platform like this supports.
Thank you, Rebecca. And thanks for highlighting XPLA as a solid example as well. All right, let's go to Yaoqi.
Yeah, thanks Khai for inviting me to this panel. So Yaoqi here. I sort of like started my research career back in 2012, mainly on peer-to-peer network, consensus protocols, and also privacy technologies. I sort of like around the underlying infrastructure of these blockchain like stuff. And then like my main focus was really on sharding and sort of these scaling solutions around public blockchains. Yeah, back in 2017, together with some friends, we co-founded Zilliqa. It's like a public sharding protocol. And yeah, later I also like joined Parity as a general manager to help them to grow the ecosystem for this Polkadot parachain. It's another like sort of sharding ecosystem. And then right now, as Ashita mentioned, like back to AltLayer, it's sort of like we started AltLayer since the end of last year. The idea that we have witnessed there are so many popular applications for the past few years. And basically, we also see a lot of high throughput L1s and L2s, but when this popular application with like million of users base, right? Typically, there's some campaigns can congest the network. So we feel that it's sort of like there are some demands among for the like elastic scaling solutions. So we started AltLayer. Basically, our AltLayer, we are providing this elastic and versatile execution environment for different applications across both EVM and non-EVM chains. Something quite special about AltLayer that it's both EVM equivalent and also YZM compatible. So that means like for developers, they can like seamlessly deploy Solidity contracts. And meanwhile, for some like sort of new libraries, we can also have the compatibility for them, even it's not insulating. Beyond that, like to really provide better developer experience, we try to make the entire like sort of experience seamless. So we try to provide like some sort of like short-term or long-term this rollup solution for them. So for Mint or some like short-term applications, we can provide the layers by set up some configurations so they can quickly launch the L2 and to do the Mint or other things. Beyond that, we also have this persistent optimistic rollup for the developers. Yeah, another cool part is that we also have relatively decentralized sort of producing or sequencing network. So it can sort of like avoid some central point of failure for these roll-up systems. And for us, right, we feel that like definitely for the future, it's sort of like for the Web3 future, right? There will be a lot of popular applications. It's quite similar to the Web2. At the beginning, everyone was focusing on the infrastructure building. Right now, it's here like yeah, Rebecca, we all focusing on the infrastructure building, right? It's basically the underlying fundamentals for the future Web3. Beyond that, definitely will be more and more applications that sort of leveraging our infrastructure to build their amazing, like sort of more scalable applications. I always use like DYDX and X Infinity as examples to show that in the future, definitely there will be more and more such applications with millions of users, right? And with the current infrastructure we have in the crypto space, like once they have some campaigns, Mint or some like sort of trading campaign, right? Definitely can sort of like bring a lot of congestions on the L1s and typically also have a lot of high gas fees during the gas war for the users. So in the future, with more and more these applications in this space, right? Definitely they need some dedicated execution layer either sort of like as optimistic rollup or like ZK rollup or Rebecca like this appchains, right? It definitely like just to help them to scale because like so many users, so many requests, you definitely need like to have a dedicated execution environment to handle this huge volume of requests. So we feel that with all different like this kind of scaling infrastructure for this popular application, right, we can have a much better like sort of future of a various and diversified application in the Web3 world. Yeah.
All right. Thank you, Yaoqi. And thanks for also pointing out some of the very Web3 native examples, right? DYDX and like X Infinity, which have already moved to their own chains.
Yeah.
I'm very excited to go into further detail after this about your AltLayer solution, which is kind of roll-ups in demand, right? At demand. All right. Yeah, let's talk about Scroll. I know we've been spending quite a bit of time on intros, so do feel free to take quite a few minutes here.
Sure. Hi, thanks for having me. My name is Ian, the co-founder of Scroll. So prior to Scroll, I mainly work on ZK research. I work on hardware acceleration for zero-knowledge proof, basically using some more customized hardware like FPGA, ASIC, or GPU to make proof faster, because that's one of the bottleneck for generating proof in practice, and one of the bottleneck why people are not using the ZK rollup because it's a high cost for the provers. And I also work on more crypto and math, or like the proving behind the ZK protocol, like how you compress a large computation into a single proof. And more recently, I'm working on the ZK application, and to build a Scroll, we are looking into ZK EVM and how you prove EVM execution is correct using a single proof. And so that's the background for me and Scroll. So Scroll is a layer 2 scaling solution for Ethereum. It's a general purpose scaling solution, and it's like more specifically, it's based on ZK rollup. And in order to maximize the compatibility with Ethereum, we are building something called ZK EVM. And currently, we are building that in a totally open source way, especially with the privacy and scaling exploration team from Ethereum Foundation, because they also think it will be the dominant part in the future for even like play a very important part on Ethereum to make that, like this metaphor for snark everything, snark Ethereum, take Ethereum distinct. And it's also very useful for layer 2 because to achieve compatibility using zero-knowledge proof, you have to build something like this. And besides the EVM part, to achieve EVM equivalent, we also have a decentralized network, which it used to be like a centralized sequencer sequencing the transactions, centralized proof for those layer 2 blocks, and then you submit this proof on chain for verification. But we decentralize this proof network where anyone can join the prover, and they can so that we can scale our proving network and to better efficiency, better throughput, higher like reliability because you have more provers in your network. Yeah, so basically like two largest components where we are building. And for the goal, like we aim to developer friendly ZK rollup. So developers will actually the same development experience on us. It's exactly the same as they do on Ethereum. They can just migrate their code onto Scroll without any recompilation, and we are compatible with all the existing toolings so that developers don't do any extra. They can reuse all the toolings they are familiar with to deploy on Scroll. So yeah, that's the intro. So as the examples of scaling, so I usually firstly start with like blockchain system. How if you are decentralized, you have 1 million nodes and doing the same computation for redundancy and it's redundant, but it can make your computation more secure because all they know that computation to reach consensus. And scaling solution is that instead of letting all the nodes doing heavy large computation, you just have one node, all those stuff doing all the heavy part and generate proof, so that every those 1 million nodes just do very small and sustained verification. So the amount of work you can see this scaling solution is that 1 million times your computation cost worth one computation, but plus like 1 million like verification. Of course, cost. But basically, you can scale in solution. Yeah, so that's some example like for this theory behind scaling solution. And also like when I went into blockchain space, the first application I played is some on-chain DeFi. Each transaction takes me maybe tens of hundreds of dollars to spend, and which is definitely unaffordable for everyone to join this space. So that's why we definitely need some scaling solution, and we are focusing on building something more general purpose because we believe this composability is very important. It's harder to do like between different appchains. Like definitely you have some needs for gaming, entertainment, as Rebecca or Yaoqi said, like there are some needs for that, some enterprise like needs, but we are more focusing on some like more native composability purpose applications. Yeah, that's basically an introduction and some examples.
All right, thank you. Yeah, and I think as we can see, we have quite a few different approaches here. And yeah, if we can continue this conversation right now, of course, you mentioned ZK rollups, and as you mentioned, Vitalik himself has snark everything, and it is quite a different approach compared to what we have seen in the past for scaling, right? Right now, there's a huge emphasis on ZK, and it's a whole new area of exploration. So could you go into a little bit more detail? How is ZK scaling different from the other kind of scaling solutions in the sense that, needing these proofs, and then like, what do these proofs enable us to do?
Sure. Yes, so for Ethereum scaling solutions, they are largely like two categories. One is called ZK rollup and another is called optimized rollup. So ZK rollup relies on some more cryptographic assumption. So the idea behind it is that if you send transactions to one like off-chain centralized node, after sequencing the transactions generated layer 2 blocks, the prover will generate a succinct proof for the batch of transactions, and the proof will be verified on chain. So this proof is saying that okay, all the batch of transactions, you just need to verify this proof efficiently, and it's mathematical between this proof verification and the execution for your transactions. So there is literally no way for you to generate a fake proof if you insert any bad transactions. Like if you just fix some transaction, you can generate correct proof because it's guaranteed by this crypto and the math behind that. And also you get a shorter finality because as far as your proof is generated and it's very, you can just take your money through withdraw. And so that's for the key rollup. And so the idea behind optimized rollup is that instead of generating validity proof, it's based on some game theory and some economic assumption on something called fraud proof, which the idea is that still one off-chain node is executing a batch of transactions, and the final state and some data validity on chain, and anyone they witness this on-chain data, this new data, they can re-execute the transaction because you bought in, and you can re-execute, and as node can catch this if some on this node are submitting some wrong state root, it can challenge this and say, okay, so this is bad, and this is correct, and they went into some challenging period by section, and they do some economics interactions, and so the on-chain verifier can determine who is the correct one and punish the bad guy. So it's basically relied on this economic assumption. So that's also the reason why it needs a longer time usually to finalize the withdraw transaction, because you need at least one on this node that it's executing this transaction correctly, re-execute this once. People usually think optimized rollup has a better compatibility, will faster be go to market because it's simpler, because you just re-execute and design this economic game, this challenge, and how you do this dissection. And also EVM compatible things impossible for ZK rollup in the past because it's such a huge overhead for building something for EVM generating proof. But it might take years to achieve this level of stability similar to optimized rollup. The recent 1 or 2 years development of zero knowledge proof, their acceleration to make this proof generation more efficient, and there is cryptographic improvement which makes how you're representing your EVM logic inside something like circuit. When you're generating proof, it's smaller, you get a smaller representation, which can improve efficiency for another order of magnitude. And companies the efficiency for the rollup currently maybe 3 orders of magnitude larger than 2 years ago. So that's why the EVM is finally possible, and you can achieve the same level of compatibility. So, and my view is that ZK rollup can provide a stronger security guarantee, very minimize file learning time, because you just need to wait for this proof generation, which is a technical computation. You found a way to make makes it faster, like in SIG or whatever way you can use. And also we do very strong public verifiability blockchain. So like earlier in the example, so blockchain is basically like 1 million nodes if you are sufficiently decentralized doing the same computation. And if you have one proof and this proof is publicly verifiable, it can be verified by like arbitrary number of nodes. Then you get a much secure guarantee. Versus in OpenZero, where you have a smaller group of people incentivized to re-execute a batch. So that's some of my opinion towards this. I definitely believe like some other people have different opinions. That's some of my opinion towards this scaling solution. And like how it compares.
Yeah, thank you. Yeah, I think the most interesting bit that I got from there is around like relying on math rather than relying on like a game theory or whatever mechanism design or like social consensus in order to verify that the state is correct or the transaction is all executed correctly. And at the same time, yeah, I want to bring on Yaoqi because I know you've been looking at optimistic rollups and also ZK rollups and being very practical in terms of like what can we use right now, right? And what's the state of development for both these rollup technologies. So Yaoqi, let's hear you chipping in.
Yeah, so as Ian mentioned, right, I believe like ZK rollup, like especially ZK EVM, I think regarding security wise, it really has a lot of like benefits. So basically, you can sort of like generate a proof like all the transactions and also state transition, right? And then you can verify the proof on the L1s like Ethereum, with very like sort of limited cost. Yeah, and regarding the optimistic rollup, also as Ian mentioned, right? So there are a bunch of like benefits or advantages. One is like it's relatively straightforward to make it like EVM equivalent. So for developers, like you don't really need to change any of your smart contract and all the existing tools. Like sort of like by default, you can deploy on the existing like most of the optimistic rollups. The main reason that because for ZK rollup, especially ZK EVM, you need to tweak like sort of the like sort of execution client to make it more compatible with sort of the proof generation. For optimistic rollup, like sort of you by default you can sort of use the client, but it's mainly on the fraud proof part, like how you generate a fraud proof. For example, you can like generate fraud proof into like sort of MIPS instructions like optimism or like Arbitrum or us, we sort of generate like into this kind of WASM instructions, so people can do the like game theory or we call bisection like this challenge way on Ethereum. At the same time, right, I don't think like there's like sort of a direct competition against like sort of ZK rollup and optimistic rollup, because right now I think it's still at the state that people can collaborate together and to really make the scaling solutions better. Because right now, like as you know, right, so due to the implementation advantages on optimistic rollup, as you can see, right, a bunch of these optimistic rollup right now already in the market and already provide like this platform for applications, especially DeFi applications, to be deployed on these platforms. And meanwhile, right, I think one of the interesting part is about this transaction history. Typically, optimistic rollup will just comprise all the transactions or like sort of have some optimized ways to strip off some of the data of the transaction. But in the end, like it will like sort of upload or submit this kind of transaction history to Ethereum. Of course, it's relatively due to the data availability issue. That's why you need upload the sort of history back to the Ethereum. But the good thing, like you will see the transaction history. Yeah, but on the other side, that's why typically we see the optimistic rollup has a higher cost compared to ZK rollup. Yeah, beyond that, I would say like as I just mentioned, right, there are different ways like ZK rollup mainly on this sort of like ZK proof and the verification on chain. And meanwhile, for optimistic rollup, it's mainly sort of like high performance and better compatibility with EVM or Ethereum. But at the same time, like on the fraud proof part, like typically there's a challenge period. No matter it's 1 week or if it's just within a few hours, but still there's a challenge period. If you really want to make sure like all your deposits are secure and when you're doing your withdrawal, right? And then basically there's a fraud proof based on this bisection like game or bisection challenge. So yeah, I would say like as you can see, right, the difference here, like you can see some pro and cons both ZK rollup and also this optimistic rollup. But in the end, I just feel like either we provide a rollup for general purpose, sort of a scaling solution for Ethereum, or we provide this rollup as application specific like scaling solution for the applications. Basically, they are really good, I mean, concept. Because in the end, we still derive the security from Ethereum. That's the most important part for rollup compared to all the other scaling solutions. It's quite similar to sharding because like sharding, like by default, you know there's a shared security among different shards, right? But here for rollup, I think it's sort of like more like execution sharding, you know? You do the execution in the rollup, but at the same time, you enjoy the benefits of the security guarantee from the L1. Yeah, that's sort of my understanding, like based on my experience for the past few years on sharding and scaling. Yeah.
Yeah, let's go a little bit further into that, Yaoqi, because as you mentioned during the intro, you were working on Zilliqa, which is then a layer 1 sharding solution. And then after that, you move to Polkadot, which has like heterogeneous sharding. There's the idea of like parachains, which are kind of like similar to rollups as well. And then now you're working like fully focused on AltLayer, which is then like Ethereum rollups. So actually, how do you see that kind of like transition, and what do you see are like the differences and similarities, and what made you kind of decide to go for this path now?
Yeah, it's a very interesting question because based on my experience a little bit unique. It's always on sharding. For me, like for Zilliqa, it's sort of like execution sharding, and then for Polkadot, basically it's a shared security. It's like different parachains. Basically, it's like different shards, and it's a shared security, right? And then right now, rollup for me, it's really like another execution sharding. It's either optimistic way or it's like Ian mentioned, right? It's a ZK with proof, like that kind of mathematical way. So from my point of view, right, I just feel like definitely there's a big transition, especially like when we did a lot of experiments on how we implement the sharding. At the beginning, we feel that like in 2015 or 16, when we invited Vitalik to give talks in Singapore, we discussed like about the state sharding on Ethereum, especially at that time Ethereum 2.0, and then later we got Plasma, right? It's another way like sort of to scale the Ethereum. At that stage, we are sort of still at the exploring phase for Ethereum or for public blockchains to use and leverage sharding. We published the research paper in the academia. The thing like even for Zilliqa, it's sort of the first time we try out this execution sharding. The good part at that time, right, we feel that on the L1, right, with proper sharding, especially the state sharding, we can resolve the scalability issues. But apparently, we figured out if we really want to do the full state sharding, right, the problem is really about the cross-shard communication. Like once you start to do a lot of this cross-shard communication, right, basically you need to lock the states and on one shard and then basically block the other shard's execution. So that's why it introduce a lot of complexity and basically, as you can see, right, from the sort of the involvement of the sharding and to the current rollup landscape and the roadmap for Ethereum, basically at that time, like we feel that it works, but in the end, like state sharding, the complexity and all things probably just not the ideal solution. And then we see like Cosmos, the IBC zone, and also this kind of hub, right? Try to build like different app chains and use the hub to do the cross chain. Or it's not to do the cross chain, it's like to coordinate different zones to do this cross chain communication. And then Polkadot further is sort of like you have different parachains at different shards, and then the relay chain is basically like it's like a big family. They are the big parents, like to really coordinate the different shards with the shared security. But the bottleneck about that part is really like you still need to have the coordination around the relay chain. Definitely you derive the shared security, but at the same time you lose some sort of like flexibility. Basically, different parachains, you don't really have all the freedom to build whatever you want, right? Not like chain or rollup. You can change like whatever the consensus and all different ways to do it, right? You lose some flexibility. At the same time, since they are coordination, so you have to wait for the confirmation from the relay chain. That's why right now we feel that sort of like probably rollup is a better way to provide the flexibility and also the shared security, right? So we derive, as I mentioned, right, like we can derive the security from the L1 like Ethereum, but at the same time, flexibility means we can really do a lot of configuration. Because in the end, rollup is really like this execution sharding. So you don't need to care about like sort of the these sort of state sharding, the cross shard or cross rollup communication at the stage, and you don't really need to worry about like state transition called different rollup. You just need to focus on your execution. So yeah, that's how I like sort of see this kind of transition for the implementation or the designs for sharding from time to time. Right now, we feel like Ethereum side, it's rollup centric, like scaling solution. And in general, probably rollup can be a really good or the ideal sharding case for the long run.
All right, thank you, Yaoqi. That's super insightful. And you've already started alluding to the Cosmos model as well. So here I'm going to call on Rebecca. I think Yaoqi talked a lot about actually the challenges and complications when you need to coordinate between shards, right? And you need to make sure they're in the same state, they're finalized and so on. And that is actually a problem that Cosmos has been solving. And in a way, it's live already, right? So being in the Cosmos ecosystem and using the Cosmos stack, would love to hear your view here.
Yeah, absolutely. So, I mean, fascinating discussion about the different kinds of rollups that Ethereum plans to use to scale out. I mean, we've been watching it very closely as well. So I'll answer the cross-chain communication piece first, and then I'll get into rollup architecture. But with respect to cross-chain communication, so what Yaoqi was referring to is something called IBC, which is inter-blockchain communication. And it is like TCP/IP. It doesn't operate exactly the same way, but we use that analogy because like TCP/IP, it is a communication protocol between two different chains. And so what you have is a chain and a light client on one side and a chain and a light client on the other side. And as long as you have verified transactions on both sides, then the assets can transfer over. So it's just communication. There's no bridging involved. It is a standardized way in which assets can freely transfer between chains that are IBC enabled. Now, every chain in Cosmos is IBC enabled. This is part of the Cosmos SDK already. And I think to date, there have been about $500 million worth in assets that have been transferred via IBC. There have never been any problems because it is very secure. Now, some people like bridging more because you actually have a bridging product there that's pretty well built out. You're not needing to integrate a full communication protocol. But having said that, once you do integrate that protocol, it's very easy to use and it is completely secure. Nothing has happened to IBC yet. It's maybe early days and we'll find some vulnerabilities in it, but so far it has held up remarkably well. So all the chains in Saga communicate via IBC. So everything that is deployed on Saga is a chain in its own right. So that includes all the applications. It also includes the Saga mainnet, of course. And so the way the chains communicate with mainnet, which is essential for our system to function, is through IBC. So we have pretty high reliance on it as cross-chain communication. So it's a nice feature. In terms of scaling out monolithic chains using either rollups or side chains or app chains. I mean, all of these have pros and cons. What I will say about the rollup architecture is, one thing that we identified early on we could contribute to in terms of rollups is, a rollup requires sequencers, which is the equivalent of validators. And the reason why we started Saga for many reasons, but one of the main reasons was that in order to develop your own app chain, you need to have your own validator set, which means you need to recruit those validators, which means you need to have a staking token. You need to incentivize those validators through a good staking token model. You need to maintain that validator set over time. And all of that is a lot of effort for a developer who probably just wants to focus on the application. And so we wanted to abstract the security layer away completely. One of the things that we noticed with respect to rollups is it may solve the Ethereum scaling or sharding issues, but in terms of getting that set of sequencers to comprise that rollup for you, that is still a lift. And so to make the solution more complete, we have begun to partner. It's not announced yet, but we have begun to partner with Ethereum Solutions to be that sequencer as a service. It does work for a protocol that is geared towards solving more Ethereum-like problems, to offer sort of a roll-up as a service, so that they can offer ultimately the end-to-end for that scaling. But that's how we see working with the roll-up architecture. Again, we're talking about rolls because it's a very sort of Ethereum-centric solution. Ethereum is so incredibly dominant in much of application development, but in terms of communication between Ethereum shards, and then talk about the rest of the Web3 ecosystem, whether you're built on Solana, Avalanche, etc. You want to be able to achieve that kind of communication as well, and that's where Cosmos can be even more interesting. But that's why we decided to try to make the Cosmos app chain automated as a way to scale out chains native to Cosmos, but ultimately in other ecosystems as well.
Awesome. Thank you, Rebecca, and for expanding our perspective, right, beyond rollups, because as you mentioned, often we're very focused on rollups. The moment we talk about scaling, people think about L2s on Ethereum itself, because there's so much innovation and activity there. But with Cosmos, there is all this new types of thinking that's happening with app chains, and also various shades in between of like app chains that can be partially secured, fully secured, by the Cosmos Hub itself, by multiple other app chains, right? And not just by one huge L1, which is Ethereum here. And actually, Rebecca, I'd love to go into a little bit about Saga as well, and what you talked about just now, being able to support Ethereum rollups. And you mentioned being able to support like Ethereum applications, and also other like customized applications like Exploit that you talked about that came from like a Cosmos chain. So how do we actually make this flexibility possible, right? I understand Saga has a huge focus on being application specific. And in fact, it sounds super customized even to the type of like environment, language, whatever it is, even like gas, so on, that the developers themselves are most familiar with. So let's talk a bit about this like application focused like flexibility.
Yeah, absolutely. So in our sort of product discovery, if you will, and designing out this product, yes, we started off with the app chain model because we were looking to make Cosmos more automated and accessible. So app chain is where we started. However, what we have come to build is really something beyond how we traditionally think of app chains. So how people normally think of app chains is one application per chain. So your own DYDX chain, for instance, or your own Axie Infinity chain, Ronin. But how we have started to think of the app chain is really dedicated block space. That's much more abstract than the app chain idea, but it is essentially what a developer wants. When you want an app chain, what you're really asking for is your own space to develop in. And you can have one application in that chain. You can have multiple applications in that chain, and nevertheless remains your dedicated block space. And so when we started to think of it as dedicated block space and not just, one application per chain, then the possibilities really open up for supporting multiple scaling solutions. And that's why we can bring dedicated block space to Ethereum. We can bring dedicated block space to other ecosystems as well. So how it would work, for instance, with Saga's current iteration. Right now, a developer is able to deploy an EVM compatible application onto a dedicated chain, so onto its own chainlet. Now, what that means is if you are familiar with Solidity smart contracts, if you already have a game or an NFT project that you've already built on Ethereum, it's very easy to port it over onto Saga. But that means that you have a separate instance of it on Saga. In order to bridge back to the mother application, if you will, the mother chain, you do need bridging for that. And we need to provide that bridging. So I don't want it to seem like, well, as long as you get into Cosmos, then you have free interoperability across all of Web3. That's not the case yet. We hope to make it the case, but for now, you still need bridging to those other ecosystems. But once that is established, then you see the possibilities. So let's take the example over to Solana. So a Solana game can deploy on Saga, and there are several that are deploying on Saga. You can migrate wholesale because you like the Saga backend core, or you can keep your instance on the Solana chain of that game, and you can build another instance on Saga. Now, again, that means that you have horizontally scaled that game, but we still need that bridging back to Solana. But that's how I think games and NFT projects that are on Saga have started to think about us as a resource for block space, as opposed to I have to put my entire application on this chain, or I have to put my entire application on an individual chainlet. It's all about block space. And then, of course, the same thing applies to something like Xplo, where they are a layer one in their own right. And in order to scale themselves, they need to find that additional block space. How do they do that without at all negating the value of their own token or breaking down the developer relationships that they've worked so hard to create? They do that by paying for additional block space on Saga. And on the front end, their value accrual on the token remains exactly the same as if they were using their own backend for block space. And of course, the developers are none the wiser. And so you see that once we get into this model of thinking of it more as block space, then it becomes incredibly flexible. Now, how do we actually do that in practice? So this is something that we will flesh out more in the coming weeks, and we'll definitely start to lean on it in the beginning of the year. But how we think of validator orchestration right now on Saga, it is very much meant to enable a permissionless deployment of VM-based applications onto a Cosmos chain. So it's specific to Cosmos shared security. You are deploying on a Cosmos backend. Now we take care of that deployment for you, but nevertheless, that is the architecture. So what we're starting to do now is we're making it possible for platforms that are more mature, so other layer ones, for instance, or other gaming platforms that have already developed their own tech stack that is not Cosmos at all, but nevertheless give them that shared security and that orchestration. And one nifty thing that we're doing there, I don't want to reveal too much because over the next few weeks, we'll be issuing some papers on this, but we've basically separated the function of providing security for a chain from providing computing power for that chain. Because a validator has several different functions. We tend to bundle them all into one function, but the model that we've created now with respect to scaling, it is entirely possible to use somebody else's validator set, use their security model, but at the same time, the computing power and the orchestration of those validators resides with Saga. So we can truly use somebody else's stack, but scale out that particular stack for them. So that's something we'll elaborate on soon. But I think what really freed us up was thinking of the app chain as dedicated block space as opposed to one app, one chain.
Thank you, Rebecca. Super interesting, right? The dedicated kind of a block space and with like your own customized parameters and developer experience allows you to then like reach many different like needs. I'd love to go directly now to the opposite with Ye and Scroll, where you just now talked about like very specifically being general purpose, right? And of course, the general purpose environment means that you have to standardize the developer experience, right? They have to follow what Scroll dictates, right? If you want to use a particular gas token, if you have a particular type way to kind of execute these transactions. So why do you decide to go down this path? And perhaps is this kind of an interim step and then we go towards something like layer 3s, which are also then like customizable?
Yeah, sure. Surely. So firstly, just to clarify, so for our zk rollup, so the principle is that be more aligned with the Ethereum through and be aligned even with the current Ethereum implementation. So even for our zk rollup, it's a zk rollup prover, our execution client is just directly for gas, which is Go Ethereum. So it's similar to optimistic rollup in terms of the client diversity. Like we can all use your execution trace from gas or some other implementations that's currently Ethereum is using, and directly output any execution trace and let our prover adapt to this execution trace. So that's how like we can modify to be compatible with Ethereum infrastructure. Like all the developers can reuse all the familiar like toolings and node and all the implementations even under the smart contract level. And so that's the second thing that as we discussed earlier, like this monolith chain like can't do the whole thing too much, like to do consensus, stability, and execution, and you have to make some trade-off. And the biggest trade-off Ethereum make is that it want to achieve better decentralization security. And so because it want to be a global settlement layer, it won't be like any. So it want to allow any node with a very small requirement to its network kind of become some validator or like make the more decentralized. So that's why like with like what should rely on the security is inherited directly from the base layer. So that's why like we build on top of Ethereum and we can inherit everything that Ethereum has, and especially the security property. And because the biggest thing that the rollup can bring you is that the security guarantee the same name layer one. It's usually it has like chain, but this bridge is permissionless between Ethereum and the layer. So that's the biggest thing. Like you can think of like it's different from any other bridges. It even verifies the whole solution on Scroll and post this proof on Ethereum. So that's why like we are building on top of that. And the third thing is that, as you mentioned, like there is a compatibility. There is a like we want to build some, because we believe, and why we choose this like such a general purpose environment is because as a layer 2, we think layer 2 be a direct scaling layer for Ethereum, because it has all that like numerous applications, DeFi, like NFT, all those applications, they congested and expensive, and we want to solve this problem, and that's a key goal for layer 2, and that's a high priority. That's why like we want to achieve Ethereum equivalency, because we can inherit everything like so the thing that layer 2 can provide, as like especially Scroll can provide, that you can port your code without any changes, and we can solve this congested issue right now by providing the same environment, by being seamless, being like you need to do very small effort to migrate your code to us, and it's secure. So that's the key goal for layer 2. And maybe there are some customized environments for layer 3 or which can build on top of us and put their state root on layer 2. But I think as a layer 2, as a layer 2, we want to solve the problem directly from them and think about some extensions like appchains or whatever. And also because I definitely believe that for appchain you can have your ecosystem, even it's not only targeting one application. You can have like on top of this chain, but the problem is that for general layer 2, if you inherit from Ethereum, you get a larger like liquidity, like swap, like all the like for DeFi you get a better compatibility. You need liquidity inside this chain, which if you are like building application specific chain, for example, you build something for game and you build some like some ecosystem around it, if not enough people, if you can't share like liquidity, which will introduce a larger within your ecosystem. So that's why we think building something this general purpose thing and this compatibility is a more important high priority for and I think that's some reasoning behind this, and we will not stop by just being this like EVM equivalent. And also, by the way, another important thing is that building the same environment. Another interesting thing is that you can also inherit all the improvement from Ethereum. So another like Ethereum has a very strong research community, like an EIP proposal to keep improving that. And if you are aligned with this implementation and this, then you can easily apply like new EIPs and all those innovations to our own community, and even like sometimes go ahead of Ethereum to try new EIPs and try some innovations. So that's why like even if you keep the same environment, but everyone like over 80 chains are working over the same environment, it can making this better and better improved. So that's why like we can reach all those efforts and like improving our own infrastructure. And one day, after making this stable platform, making it secure, making all the applications move on top of Scroll, then we can think of something more customized. Like, if you need, like we can talk with game developers and what environments they really need, what type of executions they need, and then maybe use something like on top of our layer to adapt. Yeah, that's some of my opinion.
Thank you, yeah. And I think as you mentioned as well, there are many possibilities after we are ready with this like layer 2 and with Ziki circuits that we can build on top as well. So we are already kind of pretty over time. So I like to now wrap up already with a final question here around like a future looking prediction, if you may. So let's go with Yaoqi first, right? So there's so much innovation that's happening. Everyone's building in various directions and trying to serve different like segments or sometimes similar segments. How do you think this whole multi-chain and cross-chain future will look like, let's say, in a few years' time?
In my opinion, like sort of it will be quite similar to the current internet. Like even we see that we have TCP/IP and all the standard like sort of specs and underlying infrastructure, right? But for most of the applications, especially the popular application, they still have their own server. They still have their own like sort of infrastructure setup. It's not about like why they don't use some other guys like sort of server or computation resources. It really like they need to have the control of their data and need to have, right, the GDPR and all the things. At the same time, they also want to have more flexibility to provide better user experience for the users. If we come from the developers and also the users' perspective. So at our side, right, we want to become the platform, like sort of to really provide such like flexible and also like with good security guarantee execution platform. So right, for the applications like either general purpose or like application specific like dapps, right? So what they need is about the execution layer and our side. So later we can really provide the optimistic rollup, the application specific like layer for them. And at the same time, as you mentioned, right, it's on demand scaling solution for them. So they don't need to worry about like sort of the underlying infrastructure. So they can just focus on their business sort of building and business logic. That's how most of, 99% of the existing like Web2 applications exist, right? So they just focus on like how to build like better entertainment or better usability application instead of really doing the like sort of server setup all the things by themselves. We hope like we can really handle the underlying infrastructure part by like sort of AltLayer, so we can provide like the convenient setup at the same time derive the security from Ethereum or different L1s. Meanwhile, like make the execution layer as compatible with their current tech stack as possible. Yeah.
Great. Thank you, Yaoqi. I think I hear a lot about the flexibility of like being able to then define whatever you need. And I can see all they're building towards that, right? Being able to then serve those needs with Ethereum as the security layer as well. We do just have a few minutes left. So any quick predictions, how will this multi-chain future look like in a few years' time? Let's go with Ye as well.
Yeah, like as a layer 2 project, I believe that it's gonna be horizontally like scaling, and Ethereum will become the settlement layer, and we become like one of the largest execution layer. And each layer, like different tools have their own community, and we will become the most like Ethereum line, and even give back to Ethereum community by contributing to this like dank sharding, this EIP phrase for and also invitations to make this on-chain very cheaper and increase the throughput and like the largest competitive for the graph. And eventually all the applications will move to this execution layer. And also because it's still used significantly reduce gas fee and like fast confirmation and codability, with some new innovation of applications developed Liquid already become, or Organized Rock becomes like enough for having a like large competitive to like whatever applications you have, and you can also enjoy like other like ecosystem there by on the same layer.
All right. Hopefully we'll see that Zk rollups continue to progress really quickly, and developers can directly deploy on top and be able to think about new types of applications as well that you mentioned just now. So not just what we have today. And wrapping up, Rebecca, your quick predictions.
Well, I think, so goes the user, so goes the developer. At the end of the day, the developer is building applications that they hope the users are going to love. And the fact of the matter is most users they don't want to deal with the complication that's currently Web3, especially not in gaming and entertainment. DeFi is a different crowd, but especially in gaming, which we think is really going to take Web3 to mainstream adoption, people are going to want a much better user experience, which means that the multi-chain has to be a lot more user-friendly than it is now. I mean, you can't be multi-chain right now, which means you have multiple wallets, you have multiple tokens, you have to keep track of all those assets and where things are lying. There's not even a great user interface for that. So there are a lot of barriers to entry right now for people to get into the Web3 space. But I think that we're still at that point where all these different ecosystems consider themselves to be discrete communities, and they really protect the community that they have built, and the incentive for these communities to work with one another is not really there yet. But I do think we'll get to a point where bridging as we currently know it is just not a solution that we can take forward for communication between the different chains. I think we need something far more secure than that. And that's where ultimately the users are going to push the developers, and the developers in turn are going to push the protocols. So I do think that we'll continue to have this multi-chain architecture. Ethereum is a wonderful ecosystem, obviously has the lion's share of traffic. I think it is uniquely suited to money. But in terms of other use cases and then the growth of that ecosystem, I think that others are providing a lot of value. So we'll continue to have this multi-chain Web3, but these chains need to talk to one another. And I think ultimately the users are going to force us to get there.
Thank you, Rebecca. And actually, that is also a great kind of prelude to actually all the other panels that we're going to have. We're going to cover interoperability, as you talked about, communication between chains. We're going to talk about things like middleware, where we can simplify and abstract away a lot of the user experience and make that really seamless for everybody, as well as more modular layers to add more functionalities. So for everybody, please stay tuned and also check out these other panels. And for Yaoqi, Rebecca, thank you so much for today's discussion. It's been super insightful. We could have gone on for many hours. I can tell you the list of questions that we've prepared, we barely covered maybe 10-20% of them. So certainly this will be an ongoing conversation that we love to expand in the future. Thank you again for joining us.
Yeah, thank you.
So much, Khai. Thanks, everyone.